Now, the next video is going to probably be a little bit echoey because I've run away from my kids who are making a lot of noise in the house, and I'm in the garage to film this. What we're going to have a look at is how I can use the completing the square algorithm to factorise any quadratic. And we're going to start by looking at quadratics in the form y equals x squared plus bx plus c. To do this, it's going to need some good algebra skills, so see how you go following along. You're not expected to be able to do this yourself or on your own. It's just useful to see how this actually works, because I'm going to use it for the proof of the quadratic formula in the next video. Okay, so let's start with our equation, x squared plus bx plus c. Now the first thing in our algorithm is we had to halve the middle term. So when we're doing this with algebra, it just becomes b divided by 2. Then we have to square this value, which gives me b squared over 4. Then we add and subtract, which looks like this. So we put in the x squared plus bx plus c. No, I don't want the plus c part. Let's just go back a step. What I want to put in now is my plus b squared over 4 minus b squared over 4, and then plus c. Okay, like we did with when we had numbers, those first 3 terms can always be factorised, and it will become a perfect square where this b over 2, highlighted the wrong part there, let's just go over that again. This b over 2 becomes the factor of the linear expression. So it will be x plus b over 2 all squared minus b squared over 4 plus c. Now what we can actually see in this expression is that we have turning point form. This is how far the graph will move left and right, and this is how far the graph moves up and down. So what that means is if I've got an expression that's y equals x squared plus bx plus c, then the turning point moves left b over 2 places, and it moves down c minus b squared over 4 places. So, oh sorry, it doesn't move down, it moves up c minus b squared over 4 places. Or we can say the turning point is at b over 2, comma, c minus b squared over 4. So this is my coordinate of a turning point when I have a quadratic expression in this form. So that's pretty neat, because those other strategies that we've discussed to find the turning point, we can actually jump straight to it just by substituting in the values b and c into this expression. So that can be a nice little shortcut that saves you a bit of time. I will go a little bit further though with this expression, because what we've actually got, I'll write that out again, what we've actually got here is a difference of 2 squares problem. Now the first thing I'll actually do is I'll make this second part its own factor. Now when I do that, I've actually brought out a common factor of -1, and what that does is it changes this plus sign to a negative sign. Because if I had, oh, I don't know what's going on there, if I have -1 times negative c, that becomes a plus c. Okay, let me just go back so I can get that expression looking a bit neater. Okay, so there's my expression, and here is my difference of 1, two squares, or a difference of perfect squares problem, as we've been calling them in class. So when I have a difference of perfect squares, I end up with two brackets, one with a plus, one with a minus. I need to take the square root of the first part, and it goes into the first spot. And then I need to take the square root of the second part, it goes in the second spot. And I can tidy this up a little bit further by getting a common denominator in that second part. So it'll be b squared over 4 minus 4c over 4. I've got a common denominator. And same thing again, b squared over 4 minus 4c over 4. And that allows me to take the square root of that's the 4 as the denominator in the second part of the expression. So the square root will remain on the top, and I'll have b squared minus 4c, and on the bottom it'll just be 2. X plus b squared on 2 minus, so the square root goes on the top, and the square root of 4, which is my denominator, will just be 2. So there I have a factorised quadratic using completing the square. The next video, I'll go to the next level. It gets a little bit more complicated, and we're going to use a very similar process to prove the quadratic formula. Thanks for listening.